Alright, let's look at a another example, or another way. It's very similar to the example that we did, but just another approach to it. So once again, I'm going to put a table in here with the typical cosine graph, just y equals cosine x. And let me just put it down here for reference. Y equals cosine x. And this is radian mode. I'm going to put it in initially in trigonometric axis, so that the numbers aren't going to be just whole numbers. That'll have the values that we see typically on a unit circle. So once again, typically we see points like 0, 1 on a cosine graph, pi over 2, 0. And it's important that you know these points, because the 5 points that we move around are the what I call the quarter period points. But what this basically is on the unit circle. I'll pull up the unit circle once I get these points plotted. It's the x and y intercepts of the unit circle. If you look at it on that, once I get the last one done. So this is 0, and then we're back to 2 pi. I mean, we're back to 1 at 2 pi. Over there on the very edge. So on the unit circle, you know, it's 0 radians, pi over 2, pi, 3 pi over 2, if I can get that in the picture, and back to 2 pi. 0 and 2 pi are coterminal. The cosine is going between 1, 0, negative 1, 0, and back to 1. And that's what we're seeing in this graph. These are the x coordinates on the unit circle as we rotate through those. So that's the 5 points that we are plotting are the points on the x and y axis as we rotate around the unit circle for sine and cosine. We do something a little different for the other functions, tangent and cotangent, but sine, cosine, secant, cosecant, these are like they're really important points. Okay, so there's another way to do it. Instead of making your way to the quarter points, like I start at the peak, I end at the peak, the midpoint is down below, and then the quarter and 3/4 points are on the midline. That's true. But another way you could do it is, you know that these are the 0 and 2 pi. Those are the endpoints of one period. The left endpoint is at 0, the right endpoint is at 2 pi. Well, what you could do is take this inner part. This is what causes the spread, the 2 pi that's in front of the x, causes it to get squeezed down. And the pi over 6 and the 2 pi together cause a horizontal shift in the graph. So since the stuff in the parentheses is changing things horizontally, that's going to affect this initial point and this final point in a period. So what you can do is copy that, paste that. You don't need to see the graph of it, and you don't have to do it in Desmos. I'm just doing it in Desmos because that's what I have pulled up. But you're going to set these two things equal to your left and rightmost values in the period of the cosine. So I'm setting that equation equal to 0 because that's where we start a period of the cosine. And I set that stuff in the parentheses equal to 2 pi because that is, again, where that's where we end up. So that's the initial point in a period of the cosine. That's the final point in one period of the cosine, going one time around the unit circle. And now we have two equations to solve, and we just solve those equations, and this ends up being the x coordinates of one period of this altered cosine function. So here's the work to find that, where that initial point, where that 0, 1 point goes, as far as the 0 part of it. So we set it equal to 0, and move the pi over 6 over. We divide both sides by 2 pi. Alright, fraction within a fraction, we can just move the 6 down and join the 2 pi, so it becomes 12 pi. And then negative pi over 12 pi just becomes negative a 12th. And you can actually check your work here. If you click the equation, notice that vertical line shows up. And then if you come down here to your solution, x equals a number is a vertical line. So that line is right on top of my initial setup, so I know that that's correct. So negative 1/12 is where this 0 coordinate is going to go. We're shifting over by negative a 12. Okay, and then the same thing I do for the other equation. And so there's that work. So we subtract the pi over 6 over, we divide 2 pi is the same as 12 pi over 6. So we divide 11 pi over 6 by 2 pi. Same thing's going to happen. The 2 pi will join the 6 and become 12 pi. And then that's, the pi's cancel. So we end up with 11/12. So this is my rightmost point, that 2 pi over, that 2 pi coordinate, the x coordinate will become just 11/12. So that's the rightmost coordinate, and that's the leftmost coordinate. So this entire curve of the cosine is going to live in that tiny little window. Now, how big is that window? Negative 1/12 to 11/12. That's 12/12. That's 1 unit long. And we've already seen when that number is multiplied by x, that affects the period. The period is 2 pi divided by this. 2 pi divided by 2 pi is 1, so the period is 1. So everything's going to live in that tiny little window between negative 12 and 11/12. All right, now that is our new, I'm going to make a new table, and that is our new initial point and our new final point. So 1, 2, 3, 4, 5 points. This last point is going to be my 11/12. All right, now this I'm just going to make these zeros for now. This is going to be the this is one full period. So I'm going to make this be the midpoint, the point right in the middle of these two. So once again, if I add these two together and then divide by 2, that's the average, right? That's how you get an average. Well, the number in the middle is the average. What's in between 0 and 2 pi? Pi. The average of 0 plus 2 pi is 2 pi divided by 2 is pi. So negative a 12th plus 11/12 is 10/12. Right? 10/12, that's the same thing as 5/6. And 5/6 divided by 2, once again we can combine that denominator, and I get 5/12. That's going to be the x-coordinate of the number in the middle. Okay? And then if I did the same thing, I get the quarter points, the 1/4 and 3/4 points. I'm going to average these two numbers, and I'll get the number in the middle. I'll average these two numbers, I'll get the number in the middle. So negative a 12th plus 5/12, that is 4/12, or a third, divided by 2 would be 1/6. Okay? 5/12 plus 11/12. 5 plus 11 is 16/12. That will reduce to 4/3, and then 4/3 divided by 2 is 2/3. Right now, again, this is not where the points are going to be. I'm just going to put zeros so you can see where these numbers are going to be on the axis, and you can see if they're spaced out properly. So I can see those numbers are evenly spaced. That's the x-coordinates of where one full period is going to go. So this whole entire wave, the upper point, the midpoint, the lower point, the midpoint, and the upper point are going to live in that tiny little window right there. Now, how do I get the y-coordinates for this? I can do a couple of things. Number one, I could just plug it in there and get it. But the easy thing to do here is, what I mean by plugging in there and get it, I could plug in negative a 12th in there and do the work and get a y-coordinate. But the easy thing to do is this altered the x's. That happens before cosine. Right? All this is in the parentheses before the cosine. These are going to affect the y-coordinates. So this 1 right here, we got multiplication and we got subtraction. What happens when I multiply, or sorry, when I have multiplication and subtraction? The order of operations says multiply first. So I'm going to take this 1, multiply by 3. So 1 times 3 is 3, minus 5 is negative 2. So that's where this is going to go. It's going to go to negative 2. All right, the 1, 6 coordinate, that's this guy. I'm going to multiply it by 3. 0 times 3 is 0. Minus 5 is minus 5. All right, the 5/12, that was at the negative 1. That's what it corresponded to the pi. That's the midpoint. Negative 1 times 3 is negative 3. And then negative 3 minus 5 is negative 8. So this guy will become negative 8. That's the 3/4 point. That's this 0 that we got before, so we're going to get another negative 5. And then we always end up back where we started, so this is going to be negative 2. But you can also just do the math on that number. You would get negative 2. Alright, so there is one period of this altered cosine function. And I can go up here and now graph it to check. There it is. Okay. Now, what if I wanted to keep going with this? What if I wanted to make a second period? Well, this same pattern is going to happen over and over and over again. So, I went to the right by that quarter period value and I went down to negative 5. So I know the next y coordinate is going to be negative 5. I know the one after that is going to be negative 8. And I know the one, it's just going to repeat that pattern. These are periodic functions because they follow this repeating pattern. Now, what's the next x coordinate? It's whatever the quarter period is. What am I adding to get from negative 1/12 to 1/6? What do I add to negative 1/12 to get to 1/6? Well, I can subtract and find out. 1/6 minus negative 1/12 is 0.25. It's a quarter of the period. Whatever the period is, divided by 4 is what we're adding from one number to the next. So I need to add to 11/12, I need to add a quarter. Alright, a quarter is 3/12. So the next point is going to be 14/12. And then 14/12 will reduce to 7/6. Alright, and then I just keep doing that. I keep adding a quarter to these points. And I can go through and just keep doing this as long as I want to. Alright, so there's the next list of numbers, and again I can go back up here to the top. And and it will continue to go through those points that I add on there. Okay, so once we have the location of the first and last point, we've got all of them, and we can plot as many periods of this as we want just by continually adding that quarter period to the numbers and just keeping the repetitive pattern for the y coordinates.